Hello everybody, this is Sandhya Rani, and in this video I would like to discuss about Lagrange's method of interpolation. So let us see what is Lagrange's interpolation formula and how this Lagrange's interpolation formula will be utilized in interpolation concept. So first of all, as we were discussing, like interpolation means two characteristic, nothing but two variable values will be provided to us, right? In that, if a value of one variable value will be calculated with respect to the other one, right? So therefore, x values, y values will be given. X values and y values are provided here. So where these x and y values are considered as x0, x1, and so on. x0, x1, x2, x3, x4, x5. And its respective y values are y0, y1, y2, y3, y4, and y5. Okay. So if you want to find out the y value, nothing but some y value existing between this y4 and y5, otherwise y0 and y1. If the corresponding x value falls in first half, we are going to opt to forward differences. If there's a y value falling in the second half, we are opting backward. So when does this Lagrange's interpolation formula will help us? Means whenever there are no equal, like you see, this x0, x1, x2, x3, x4, x5 are not evenly distributed here. Means in previously forward and backward two cases, this successive x values will possess a common difference. But whenever it doesn't have this common difference, we can opt this Lagrange's interpolation formula. This is one method. The another one is if the required y value is almost nearer to the middle part of this data, then also we can opt this Lagrange's interpolation formula. So what is this Lagrange's interpolation formula? Means y is equals to f of x equals to, first you see here we have highlighted y0, y1, and so on till yn. So if you observe only the first term y0 is here, right? So x minus means here in the numerator x0 will get missed. Other than x0, we need to take remaining all x values, that is x minus x1, x minus x2, so on, x minus xn divided by the missed x0 should be considered in the place of x here and rewrite the numerator, that is x0 minus x1 into x0 minus x2, so on, x0 minus xn into y0. This y0 is the corresponding value for x0 plus next one you see x minus x0. Here x1 is missing. X minus x0 into x minus x2, so on, x minus xn divided by x1 minus x0 into x1 minus x2 into so on, x1 minus xn into y1. So here x1 is missing, here x0 is missing, and the next term x2 will be missing, so on, till it will be continued for yn. So in this way, Lagrange's interpolation formula will be defined. After knowing about Lagrange's interpolation formula, let us discuss how this Lagrange's interpolation formula will be utilized in solving y values. So here you see, here they have given x0, x1, x2, x3. They have given x0, x1, x2, x3. Instead of table format, they have given like this, and the respective y values. And what we are supposed to find? Here we are supposed to find y of 10 value. And here this 10 value lies nearer to the middle one. Why? Because x0, x1, x2, x0, x1, x2, x3 are divided into two equal halves. Then what happens? Then we can consider this 10 as a middle one. Okay, this 10 will be considered as a middle one. Almost it falls nearer to 9, right? So, and here this x values are 5, 6, 9, 10, and they are not equally distributed. So we need to consider Lagrange's interpolation formula here, right? So first x0 will be missing, next x1 will be missing, next x2 will be missing, next x3 will be missing. So depending upon the number of values of x provided, we need to write the number of terms in the Lagrange's interpolation formula. Thereafter, we have all the values in the given information. So let us substitute all the values. After substituting, we can have f of 10 value as 14.6663. Why? Because you see everybody, x is nothing but 10 here, and x naught is given, x1 is given, x2 is given, x3 is given. We can substitute. Their respective y values are also provided now, y0, y1, y2, and y3. So everything should be substituted in the Lagrange's formula for required y of 10 values, that is 14.6663. Okay, so this is about Lagrange's interpolation formula. By using the same Lagrange's interpolation formula, we can calculate the polynomial. What does this polynomial mean? This polynomial represents a relation between x and y. So what happens, you see, in this example, we can say x0 value, x1 value, x2 value, x3 value, right? So therefore, their respective y values, nothing but y0, y1, y2, y3. They have given us f of x0, f of x1, f of x2, and f of x3. Okay. And now here they did not ask any value to calculate like f of 4, f of 3, f of 1.5. So directly x should be considered as x only. Since we have x0, x1, x2, x3, 4 values, we need to consider 4 terms in the Lagrange's interpolation formula. Like this, 1, 2, 3, 4 terms. Later on, x should be remained as x, and remaining all values should be substituted in the Lagrange's interpolation formula. Okay, so therefore, after simplifying this, by putting x equals to x and x0, x1, x2, x3, and by f of x0, f of x0, f of x1, f of x2, and f of x3 value, we are going to have the Lagrange's polynomial here. Okay, so this is all about Lagrange's interpolation formula.